Hello and welcome to LFI Educates. Today we are going to start this chapter, this motion in a plane. Now earlier I said that whenever we take coordinates like this is x-axis, this is the origin, this is y-axis, then a plane is formed here. It is called our xy plane. So to study the motion of objects in a plane, we are trying to attempt here in this chapter. Now there is not only xy plane. When I draw this z-axis, that as I said already, that z-axis will exist this way. The plane that exists between y and z-axis, this is called your yz plane. This is your yz plane. And the plane that exists between x-axis and z-axis, we call it as, this plane we call it as xz plane. So there are three planes in a three coordinate system. This is your xy plane, but here we will be focusing on one plane alone, that will take generally xy plane. To understand the motion of objects in a plane, we need to know about vectors clearly. What are the different types of vectors? Let us see now. Types of vectors. Let me start with magnitude of a vector, or we call it as modulus of a vector. Modulus of a vector, suppose in books you will get like this written, suppose this is a vector quantity, you will get thick writing like this. But we cannot do all the time this way in our notebook or on the board. So what we are going to do is, vector we are going to represent as like this. A will write the vector. If you are writing velocity vector v, you write v and you put one arrowhead on the top. Then you should understand that this is a vector quantity. Now the modulus of a vector, suppose this is your vector. If I take the modulus of the vector, if I place parallel bar here, we can write this simply a scalar quantity. This is called the modulus of vector, and we write it as a. Now the second one that we'll have to know is about unit vectors. Unit vectors are those vectors whose magnitude is 1 or unity. Unit vector we write it as cap. We put here cap, or we can call it as hat. A hat. You read it as a hat, or you read it as a cap. Like this. A unit vector is a vector whose magnitude is unity. Its magnitude is always 1. A unit vector can be represented as the vector itself divided by the magnitude of the vector. The modulus value that you have learned here, modulus of a vector, we can write like this also. This can be written as the vector itself divided by the magnitude of a. This will give us the unit vectors. And in our Cartesian coordinate system, x-axis, y-axis and z-axis, if we take like this, unit vector along x-axis we take it as I cap. Unit vector along y-axis we take it as j cap, and unit vector along z-axis we take it as k cap. It is fixed. You'll have to keep in mind. Along x-axis, the moment you see one value, suppose 36 I cap, then you should understand that this value 36 is along x-axis. It represents the value of x-axis. If you see j cap here, then you should understand that the value represents for y-axis, And if you see k cap, you should understand that the value is representing along z-axis. Then let us say about equal vectors. Two vectors are said to be equal if they have the same magnitude and same direction. Then the two vectors are said to be equal. Suppose this length is showing you vector A. Another vector I am drawing here, say vector B. They have the same direction. You can see the arrowheads are pointing towards the right, and the magnitudes, you can take the measurement like this. They are both equal. So if the magnitudes are equal and if the directions are also same, then the two vectors are said to be equal. This represents equal vectors. Then let us say about null vector. The word null means zero. If a vector has zero magnitude, then the vector we call it as null vector. Then let us see the fifth one, that is coplanar vectors. If vectors are lying on the same plane, suppose this is your xy plane, I have taken two vectors. It can be in any direction. Suppose this is vector A, this is vector B. Now these two vectors, if I draw here in xz plane, under two vectors C and suppose say D, this one. Now these two vectors A and B are coplanar because they are lying on the same plane. But A and C are not coplanar because they are not lying on the same plane. So you can say that if two vectors are lying on the same plane, then the vectors are said to be coplanar vectors. Then the next vector we'll learn is about collinear vectors. Two vectors are said to be collinear if they are pointing along the same line, like this. Suppose this is vector A and vector B, or if the two vectors are along the parallel lines, either they point to the same line or they are parallel to each other. It can be even anti-parallel also, or it can be even anti-parallel. It does not depend upon the magnitude. The length of the lines you can see here short, this is long, doesn't matter, but they must be either parallel or anti-parallel like this, or they must be along the same line. Here also it can be this way also, it can come this way also, along the same line of action, and here parallel. So all these vectors, this is one set of collinear vectors, this is one set of collinear vectors, this is one set of collinear vectors, and this is also one set of collinear vectors. So it must be along the same line, pointing whichever side it may be. They may come like this, they may go both this side, or they can be parallel also. It does not depend upon their magnitude, or they can be anti-parallel also, like this, anti-parallel. This is parallel, this is along the same line, this is along the same line but in opposite direction. All these vectors will call it as collinear vectors. Then let us see the seventh one, coinitial vectors. Number 7, coinitial vectors. Coinitial vectors are those vectors which start from the same point. If all the vectors are starting from the same point, then they are said to be coinitial. this is A, B, and this is C. So as all of them, vector A, vector B, vector C, all are starting from the same point, so the vectors will be called as coinitial vectors. Negative vectors. Negative vectors. Two vectors are said to be negative. One is negative of the other. If suppose this is vector A pointing in this direction, they are of equal magnitude but opposite in direction. You can see here the magnitudes are equal, their lengths are equal, but the directions are different. So this type of vectors we call it as negative vectors. This is positive and this is negative. So this vector is negative of A. That is your negative vectors. Then lastly, orthogonal unit vectors. Let us see. Orthogonal unit vectors. If the unit vectors are perpendicular to each other, then those vectors are said to be unit orthogonal vectors. Generally, this diagram that you can see here, in this diagram, these three vectors I cap, j cap, and k cap, we know that they are mutually at right angles to each other. Here it is 90 degree. Here this z axis is pointing like this, so it's making an angle of 90 degree with x axis. This is also 90. This is also 90. So these three can be called as orthogonal unit vectors. Here I cap, j cap, and k cap all are orthogonal unit vectors. And I cap here, it is equal to the vector itself. I cap is representing x axis. Vector along x axis divided by magnitude of x. J cap, here it is the vector y divided by y itself, the magnitude of vector y, and k cap is equal to z divided by the magnitude of z, or you can write this simply z. This one you can write it as value you can use. This is y divided by modulus value you can use. This one you can write like this also, you can write like this also. If you keep the parallel bar and put one arrowhead, that represents the magnitude of the vector x. This is z vector divided by modulus value of z vector. This way also you can represent. They are called orthogonal unit vectors. So these are some different types of vectors you come across. Now let us see multiplication of vectors by a real number. Multiplication of vectors by a real number. Suppose you have a vector A with you. This is the length of the vector. This is representing vector A. So vector A is, suppose, say 3 units. Now what we'll do is, when you are going to multiply this vector A, if I am going to multiply by 3A, then I'll do 3 into vector A is 3 itself, so 3 into 3 will become 9 units. So if you multiply by 3, it will become, this is 3, then this is 6, then this is 9. It will become this much length, it will represent 3A. It's very simple, you can see very clearly that if it is 1 centimeter, then 3 times if you multiply, then the length will increase 3 times. It will become 3 times vector A. Multiplication can be done with positive as well as with negative numbers. Suppose this is vector A. If I am multiplying with minus 2, suppose if I am multiplying, then this vector direction will change. This is 1 and again 1 more. because I multiplied with minus 2. So you can multiply with any real number, but you have to be careful that if it is positive, it will go in the same direction. If you are multiplying with negative, it will represent in the opposite direction. Resultant vector, generally we write it as R. It is the sum, algebraic sum or the vector sum of the vectors. Suppose two vectors are given to you here, A and this is B, suppose, pointing in the same direction. Then how to find the resultant? R, you will write A plus B. So it will be positive. B, this both are in the same direction, so it will be positive. And resultant vector is a single vector. After adding them, what the result you get, that we call it as resultant vector. So A and B, two vectors, when you are adding it, the resultant vector will be represented by A plus B. Suppose if it is 2 cm, this is 3 cm, then altogether it will become 5 cm, that will be your resultant vector. And it must have direction, because we are talking about vector quantity. Direction will be the same. A and B both pointing from left to right. So resultant vector's direction will be from left to right. But case 2, this is case 1. But if you get two vectors like this, one is pointing towards the right, one is pointing towards the left. This is representing vector B. Now you want to do, or you want to find out the resultant of both the vectors. Then what we'll do, R will write A, positive side, we'll take it as A, but B is on the other side, so we'll take it as minus B. Like this it will come, A minus B, and this will be the resultant. Now which is bigger, whose magnitude is more? Then we know that magnitude of B is more, so the resultant will be pointing towards the left side, from right to left. Your resultant will be like this, from right to left. That will give you the resultant. If it is of magnitude 1 centimeter, say, this is 2 centimeters, say, 1 minus 2 will be minus 1. So the length will be short, like this only it will be, but it will be in the opposite direction. This value will be minus 1. So it will be pointing in the other direction, negative direction. And if A vector is bigger than B, then it will be pointing towards the right hand side. It will be pointing from left to right. Whose magnitude is more, that side the vector will point. So this is about the two types of, the two ways you do while finding out the resultant vector. Then condition to get zero resultant vector, let us see. Suppose if three vectors are acting, as an example, with two vectors you can get zero resultant vector if two vectors are acting also. Suppose this is point O, vector A is acting this side and vector B is acting this side with the same magnitude. Then we know that the resultant, it will be A minus B, and then it will come out to be 0. This is the first case. The second case is that if suppose more than two vectors are there, they are pointing in the same direction like this, in the same order we say. Again, this vector is closing side of the triangle, is pointing in the same order, all like this is forming one round, you can see. In that case, the vector will be called as, the resultant vector will be 0. R is equal to A plus B plus C is equal to 0. Then the body will be in equilibrium. There is a state of equilibrium. Here also the body will be in equilibrium. Just think like this. Suppose 5 Newton of force you are applying this side to this body, and then this side also 5 Newton of force you are applying, like a tug of war match. Both the parties are pulling with same force. Then where this object will move? It won't move anywhere, it will remain in the same place, and that place we call it as equilibrium position of the body. Like that here also, when the vectors are given in the same order, then the resultant vector comes out to be 0, then the object will be in equilibrium. It's like this is the body. I am applying here some force. Somebody is applying force from this side also, somebody is applying force from this side also, but the body is not moving anywhere, suppose. Then the net resultant value of force will become 0. Like in this case also, if you see any structure like this, any polygon of any number of sides, if the vectors are pointing in the same order, this way, it's going like this, like this, like this, like this, like this, and ending up here again in the same circular way, then the resultant vector will come out to be 0. It's not necessary that it should go always anti-clockwise. It can be clockwise also, but you have to be very careful. Look the arrowheads properly. This way going, and this ending part, if it is not going this side, it is going on the other side, then the resultant is not 0. Then the resultant will not be 0. It must be in the same order, all going in the same direction. Then only the resultant vector will be 0. Now we'll discuss about addition of vectors. First of all, graphically we say, or geometrically also we can say. For addition of vectors, we have some laws. The first law is triangle law of vector addition. This law states like this: if the sides of the triangle, if the two sides of the triangle are taken in the same order, the moment we take the two sides of the triangle as vector, then they will have magnitude and direction. Suppose A and B represents the two sides of the triangle taken in the same order, then the closing side of the triangle, this is the closing side of the triangle, taken in the opposite order, this side will give you the resultant A plus B. This law is popularly known as triangle law of vector addition. Here is very simple. You can see the two sides are taken A and B in the same order. That's why the closing side of the triangle taken in the opposite order, this side. Not coming this way, it is going the other side. It can be like this also. Suppose this is vector A, then this is vector B. This time is pointing like this, then it should come down this way, but not coming down, it is going up. Then this will represent the resultant A plus B. This law is known as triangle law of vector addition. The second one that we have to know is about parallelogram law. Parallelogram law of vector addition. In parallelogram law of vector addition, we take coinitial vectors. Suppose two vectors are starting from the same point that represents the adjacent sides of a parallelogram, like this. So this is one side of the parallelogram, this is the other side of the parallelogram, and in parallelogram we know that the opposite sides are equal and parallel. So naturally you will know that these two must be equal, direction also should be equal, length also should be equal. You learned about equality of vectors. Then this one, this side, you will show this way, direction same, magnitude also same, they are parallel. Suppose this is vector A and this is vector B. Then this is also vector B, opposite sides are equal, and this is vector A. Then the diagonal originating from the same point, from O the two vectors has originated A and B. The diagonal originating from the same point will give you the resultant vector A plus B. This law we call it as parallelogram law of vector addition. You can look very carefully. Vector A and B, they are coinitial vector representing the two sides of the parallelogram. Then the resultant will be given by the diagonal passing through the same point, it is O. So this will give you the resultant vector. Then the third one that we will learn is about the polygon law of vector addition. Polygon, when you say, many number of sides, 3, 4, 5, 6 of sides it will have. Suppose these are the vectors. Suppose I am taking vector A, this is vector B, vector C, vector D, and suppose this is vector E, and then this is the closing side, suppose. Then I will take it in the opposite order. Then this will give us the overall resultant. Here, this length will give us the overall resultant. Then here what you do is you apply this resultant will be how much? Then R is equal to the sum of all A plus B plus C plus D plus E. The vector sum of D plus E. Everything will come here. So this is an extension of triangle law. You can look here, vector A, vector B, they are in the same order. So this resultant will be how much? Then first of all, which side to give the arrowhead? This side. Taken in the opposite order. So it will be A plus B. Then here, if you join it, these two are the vectors now in the same order. So the closing side, this side, will give us, this is the starting point. It will give us the resultant, that will be A plus B plus C. A plus B plus C. Then again these two are the vectors in the same order. So the closing side will point this side. So it will be A plus B plus C plus D. A plus B plus C plus D. Then again these two are the vectors in the same order. Then this will be the resultant. So it will be A plus B plus C plus D plus E, that you can see here. A plus B plus C plus D plus E. This law we call it as polygon law of vector addition. Now let us see the subtraction of vectors, how to do geometrically. Suppose this is vector A, like before we have taken, and this is vector B. They are in the same order. If you want to subtract it out of these two, any one vector, you can reverse it. Suppose this vector, if I take it in the opposite order, then it becomes minus B vector. And the resultant you can find out here. They are in the same order now, in the opposite order. Decide where to put the arrowhead, and R will become A minus B. It is very simple. You can see here. Actually, we are adding only, but one vector we have reversed it. Then it will come as minus, and then we call it as subtraction of vectors. Thank you and have a nice day. We'll come with a new topic in the next video.